So this is a follow-up to probability 26A, and in 26A we were looking at a 3-game series, and now we already have the tree diagram done for us for a 5-game series between these two teams where the Sparrows have a probability of 3/4 of winning any of the games. So now what we want to do is look at how some of these probabilities are determined. So if we look at this tree diagram, and it's just basically taking the games, and so first game, second game, third game is right here, so this is game 3, and then game 4, game 5, and in some cases it's done after 3 games, because if the Sparrows win in 3, it's done. If the Crows win in 3, it's done. And so then if not, then we go on to the 4th game, and then again, if not, if they're tied after 4 games, then we go on to that 5th game in the series. And so if we look here, they actually give us, this is like a winning percentage, or the chance of them doing, and they give it in a decimal form. And so we want to see, how do we come up with this decimal form 0.429 for the Sparrows to win in 3 games. And there's only one scenario where they win in 3 games, and it's right up here. And we know that the probability of the Sparrows winning any one game is 3/4. So we could put that there, and then another 3/4, and then another 3/4 of a chance. So really, this scenario, winning in 3 games, is set up by this set of 3/4 times 3/4 times 3/4. So now we have 27. 3 times 3 is 9 times 3 is 27. 4 times 4 is 16 times 4 is 64. So you have 27/64. So how did they come up with that 0.429? In this case, the 3/4 times 3/4 times 3/4 is 27/64. Well, if you just take your calculator and you go 27 divided by 64, and there you get 0.42, and in this case, I think their answer is a little off, so we would want to round that off to 0.422, not 0.429. I think they were looking at the one past it. So we have 0.422 is the probability, and really we could change that to percent. We could say that that's 42%. So now we have the fraction, we have the decimal, and then we have the percent of the time that we would expect that outcome for the Sparrows to win in 3 games, just right off the bat in this particular series. So how do we, what it would be for them to win in 4 games, and they have this number here. So we have to look at the situations where they win in 4 games. So where would they have won it in 4 games? Well, they would have won it in this one, and this one, and this one. So those 3 situations where they would win it in 4 games, and those 3 situations are actually all going to have the same probability, because in each case you have the Sparrows winning 3 and the Crows winning 1. And you could just rearrange that however you want. You've got these different situations, that one, this one, and that one, where the Crows win a different one in that set of 4 games, somewhere in there. And it's generally not the last one. So really we could actually take the probability we've already calculated for this one, the 27/64, and just multiply it by the 1/4. So we're going to take the 20, because these 3 represent 27/64, and then times the 1/4 of this one that we have to add on, because somewhere in there they won a game. And so now we're still going to have 27 here, but now we're going to have 64 times 4, which is 256. So now we have a pretty big sort of differential there in that. But each one of these, there's 3 scenarios for that. So we have 27 over 256 plus 27 over 256 plus 27 over 256, because there's three ways for this to happen. 1, 2, 3. And each one of them is 27 out of 256 is the probability of it happening. So now I have to add these 27s together. 27, 54, 54, 81. So now I have 81 out of 256 is the likelihood of the Sparrows winning in 3 games, in 4 games in this case. So we have the 3 scenarios where they win in 4 games. And so if we take that 81 divided by 256, which is our probability, then we get 0.316 and not 0.316. So that was all of those, that 27 out of 256 plus 27 out of 256 plus 27 out of 256 equals 81 out of 256, or 0.316, or 32% that they win in 4. So continuing on now, what about winning in 5? So what are the scenarios where they win in 5 games? So we've got to look at all the situations where the Sparrows win. So there's one where they win in 5 games. And then there's one where they win in 5 games. They got 3 there. And then if we keep going down, here's one where they win in 5 games. And then here's one where they win in 5 games. And then right here, they win in 5 games. So, oh, and there's one more right there. So now I have 1, 2, 3, 4, 5, 6 different ways for them to win in 5 games. And really, they're all the same probabilities, because we have Sparrows. We have 3 times that the Sparrows win and 2 times that the Crows win. So again, I can go back and set this up. If I know that it's 3 times that the Sparrows win and 2 times that the Crows win, and again, I can go ahead and just take the probability that I already had in this one, 27 over 256, and think of it as if I added one more win for the Crows. We have these 3 times the 1/4 times another 1/4. So I have 27 over 256 times 1/4. So we still have the 27 on top. And now the 256 times 4 is 1,024. And that's the probability that the Sparrows win in 5 games in each one of these different, or 6 different scenarios where they win in 5 games. So again, I'm just going to take this number and I'm going to add it together 6 times, because there are 1, 2, 3, 4, 5, 6 different ways that it can happen. Now I know this is getting really complicated, so we've got to keep track of all these numbers. 27 over 1024 plus 27 over 1024 plus 27 over 1024. These are each of the different ways, plus 27 over 1024. And I keep going until I have 6 of those, because there's 6 different ways that can happen. And what I'm left with is 27 times 6, or 162 out of 1,024 for the different ways that they could win in 5 games. So if I take that, this time I'm just going to write it down here, 162 out of 1,024, 162 out of 1,024, and I divide that out I'm just going to put that in my calculator. The 162 divided by 1,024, and I get 0.158, which is exactly what they got. Or I could write that as 15.8%. And so now, finally, if I want to think about all the ways that they could actually win the series, it's all of these added together. So I'm not going to go through all of the calculations of all these, but there are all these different ways that the Sparrows could win. They could win this way, this one, this one, this one, here, 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 and here. So we think about all the different ways, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different ways that they could win it. And all those probabilities added together, just like all of these probabilities added together, should add up to this whole percent, or this 0.903, or 90%. This is really 90.3%. And I can really check my work just by looking at my percents and say, does 42% and 32% and 15.8%, is that approximately, I didn't put these in the 0.9, this should be 42.9, add up to 90%. And so if I just take those numbers and I go 42.9% plus 31.6% plus 15.8% should equal 90.3%. So each of these all adds up to the probability of 90% chance that they will win the series, because they can win in any one of these different ways. All of these added up together give them the greater probability of winning. So again, very complicated. This is about as complicated as a problem as you can in tree diagrams. When you have multiple events, multiple different ways of something happening, and then having to first multiply across and then add the different types of situations together to get the total probability for any one particular event.